Good morning, friends. Welcome back. Today, in the continuation of the previous topic, CPU scheduling algorithms, we will be discussing some of the important problems that are related to CPU scheduling algorithms. These problems are very, very important when you see into the view of your university semester examinations, or if you want to write gate examination, or for any other competitive examinations and theoretical exams, there will be definitely a problem based on CPU scheduling algorithms. Now, as we have seen, the first CPU scheduling algorithm is first come first serve algorithm. Now, as you can see, my dear friends, there is a process ID, arrival time, and burst time of five different process given to you. They are telling us that the CPU scheduling policy followed is first come first serve. They are asking us to calculate the average waiting time and turnaround time, my dear friends. We have seen the formulas for calculating the average waiting time and turnaround time in the previous video of our scheduling algorithms. I kindly request all of you to try out this problem. I will give you 2 minutes time. Please try out this problem, and after which I will be showing the solution and explaining the problem to you. You will understand up to which extent you have understood the first come first serve based algorithm, and up to which extent you are able to solve the particular problem. Okay, friends, I'm giving you 2 minutes time. Please try the problem and try to find out the answers and construct a Gantt chart. Your time starts. Okay, friends, let us see the solution to this problem. Friends, as you can see on my screen, this is the Gantt chart that is obtained for the above problem, and the table, the turnaround time and waiting time are calculated as 48296 and 05083. These are the particular turnaround time and waiting time for the particular process. My dear friends, now I will explain how this Gantt chart is being constructed with the help of the given table. My dear friends, as you can all see, the CPU scheduling algorithm that is adopted in this particular problem is first come first serve. As the name suggests, the process which arrives first will be attended first by the CPU. So, from this statement, we can clearly infer that the process are mainly satisfied according to their request based on their arrival time. So, definitely, arrival time is the major thing that we have to consider while we are drawing a Gantt chart for this kind of problem. If you see, among all the given process P1 to P5, process P3 is having the arrival time 0, which means that this process need to be attended first by the CPU according to the first come first serve CPU scheduling algorithm. So, as you can all see in the Gantt chart, process P3 is attended first by the CPU, and it has been run for 2 units. You may ask us the question, why it has only been run for 2 units? Because, my dear friends, as you can see in the table, the arrival time of the process P3 is 0, and the burst time of this particular process is only 2 units. As I have already told you, Burst time is the number of units that a particular process is allowed to execute with the CPU or work with the CPU. So it indirectly tells us how much time or how many units of CPU need to be allocated to the process to complete its input output operation. As you can all can see, process P3 has arrived at 0. It has been given 2 units as burst time to us. So it has been executed for 2 units in the Gantt chart, and after 2 units the process P3 is being sent out of the CPU because its burst time is over. It has completed its IO execution and it has terminated. Now my dear friends, let us increment the arrival time by 1. Now the arrival time becomes 1. As you can all see my dear friends, there are no process arriving at 1. As you can see, 35054, there is no one present in arrival time, which means that there is no process arrived at arrival time 1. Now you can see, let us increment the arrival time by plus 1 again. Now arrival time becomes 2. Even at arrival time 2, there is no process. There is no process had I arrived. So the queue is empty. The CPU is idle. So again, process P1 is arriving only at the arrival time of 3, which means that the particular CPU is idle from 2 to 3. As you can see in the Gantt chart, from arrival time 2 to arrival time 3, there are no other process arrived in between. So the particular Gantt in the Gantt chart, it is marked as blank space, which means that the CPU is idle. It is not working with any of the process. My dear friends, be clear. This black box indicates that the CPU is idle and it is not working with any of the process. It is free. Now at the arrival time 3, you can see that process P1 has arrived and it is running for 4 units. Now it has entered at 3 and it is running for 4 units. 4 plus 3 is equal to 7. So at the 7th unit, this particular process will be thrown out by the CPU because its execution is completed, its burst time is completed. So at this particular point of time 7, the process P1 will be thrown out by the CPU, my dear friends. Process P1 has arrived at the time 3. So when the time is 3 in the Gantt chart, it is given a chance to work with the CPU. The burst time of this process P1 is 4 units. So immediately after 4 units, it has worked. So 4 plus 3, seventh unit. After the 7th unit, this particular process will be thrown out. Similarly, now let us check at the 7th unit if any other process has been arrived. By 7th unit, remaining all process will be arrived. Process between 4, 5, 6 will be arrived. At, you can see process P5 has arrived at 4 and process P2 and process P4 had arrived at 5. Now, my dear friends, what you have to do is, according to the arrival time, after this particular process P1, P5 will get the chance because its arrival time is 4. Over P5 will get, it will execute for 3 units, so it will go up to 10. At 10, P5 will be sent out. Now you may encounter a problem. You may ask us a question, my dear sir. You are telling that you should give the CPU based on the arrival time, but let us see, sir, in the question, process P2 and process P4 had arrived at the same arrival time 5. For which process should I consider the CPU, sir? Whether I should allocate the CPU to process P2 or should I allocate the process to CPU to process P4, sir? How shall I decide? My dear friends, for this conflict to be resolved, when two particular processes are having the same arrival time, we compare them on the criteria of process ID. That is why each and every process is given with a process ID, so that when a particular CPU scheduling policy is implemented to all the process, when there is a conflict between the two processes with the same arrival time, process ID comes into play. The process which is having the least process ID will be given the chance with the CPU, my dear friends. Now, as you all can see, at the fifth unit of arrival time, process P2 and process P4 had arrived. Now, as the arrival time of these both processes are same, we will compare the process ID. What is the ID of process P2? Process ID is 2. What is the process ID of process P4? 4. Among 2 and 4, which is first? 2 is first. So, we give the CPU to process P2. This is a very, very important step. And many of the people make mistake here. I once again repeat, friends. When the arrival time of the process is same, we mainly allot the process to the CPU based on the process ID. The process that is having the least number of process ID or least process ID will be given to the CPU. As you have seen in the Gantt chart, process P2 is having less ID. ID is less. As you all know, 2 is less than 4. So process P2 is being allotted to the CPU. It is being run for its entire burst time 3 units, and it went to 13. Now after P2 has completed its execution, there is a chance to P4 where it has run for 5 units, again 1 unit, and where the time went to 14, and all the process have successfully completed their execution in the with the CPU. This Gantt chart represents the execution of the process. Now, this turnaround time and waiting time. Now, let us calculate the exit time for each process. How is exit time calculated? You can see first P1. P1 has entered at 3 and has exited at 7. So the exit time is 7. As you can see, friends, there is only one time repetition of P1. No other way P1 is repeated. So 7 is the exit time. It is fixed. Similarly, for P2, 13 is the exit time. Like that, you will be calculating the exit time. Now, as you all know, turnaround time. What is the formula for turnaround time? Turnaround time formula is the completion time or exit time minus arrival time. You will be performing the calculation, you will be getting the turnaround time. My dear friends, now I will be giving you one more problem. Please try this problem and calculate the average waiting time and turnaround time as how I have told you in the for the previous problem. You please try out and draw the Gantt chart. I will give you 2 minutes time and I will be displaying the solution immediately once you can verify your answer. Okay, my dear friends, now we will be seeing the solution to this particular problem. As you can see, this is the Gantt chart for the problem. Process P1 has entered at 0 as it is arrived at 0. It has left the CPU by running its burst time of 2 units. From 2 to 3, the CPU is idle. Now again the process P2 has entered at time interval 3 and as process P2 has having only burst time 1, it has executed up to 1 unit until 4. Again 4 to 5 there is no process arrived, so the CPU is idle. At 5 particular process P3 has been arrived. It is been given to the CPU up to 6 units. 6 plus 5 is 11. So at process 11th unit the process P3 will be exited. Now, the basing on the exit time, the turnaround time and waiting time is calculated. My dear friends, in today's lecture, we have seen the problems on first come first serve CPU scheduling algorithms. In the upcoming videos, we will discuss problems based on the remaining CPU scheduling algorithms, which are very, very important, friends. Thank you. I request you to practice these problems once and again so that you will have a strong grip on the particular problem. Thank you. Thank you, friends.